going to look at number 3 to start with today.
That's when you go to your...
So the first thing we need to do is pick our angles. I'm not waiting for us when we stand around chalking the whole time. So we're just going to start going. So we need to pick our angles so that we can find our values. What shape is this going to be? If we have r equals theta, what kind of graph is this going to look like? So it's going to be our spiral. This is going to be the spiral of Archimedes. So let's see what that's going to look like. Our spiral of Archimedes, it doesn't have a period length. So we're just going to go for a while. And pretty much I stop filling these in when my points wind up leaving my graph. So once we get out to our radius being more than 5, that's when we're kind of going to stop. So we're just going to start, we're going to go, and we're going to keep trucking. So if our theta is 0, because that's an angle we know, that's this guy here, what will our radius be? 0. So right there. What if our radius, or our angle is this one, our pi over 6? Pi over 6, but that's going to be tricksy to graph. What is pi over 6 as a decimal? Shoot.
5,
So graphing wise, when we're graphing stuff, 0.5-ish, yeah. So we know angle 0, we're right at the center. Pi over 6, we're at 0.5. So then our next one's pi over 4. 0.8. So we're almost out to 1. So somewhere in there. Then let's look at our pi over 3. Yeah, I mean, and some change. I have it at about 1.1, but 1.
1.486. Oh, I think I put it wrong.
Hang on a second. Well, oh, yeah, you're right. 1.047. I was like, mine, I think I had it as 1.05, and then I rounded from that. So, yeah. 1.047, 1.05, or just 1. Let's see. If you want to do 0.05, you totally can. I think I had it written like that, and then when I remade the notes, I rounded from that. Is why I had 1.1. So I rounded off of a rounding, and that's bad. So then let's keep going, because we're starting to get kind of a view going on here. What are we going to get for pi over 2? 1.6. So now we're starting to get out here. And we're starting to see what's happening. It's looking kind of like that. But we're going to keep going. So our next angle that we have, we've got our 2 pi over 3. 2.1. So we're going to be over here. All right, 3 pi over 4. It's 2.4. So we're going to be 2.5-ish out here. And then our 5 pi over 6. 2.6. Yeah, and then we're up to pi, which hopefully we don't need to type in the calculator. 3.141592653, blah, blah, blah. So 3.4, or 3.14, excuse me. So right here, so we've got this kind of top half of our graph so far, and we can see that if I was to connect these up, it's starting to kind of spiral for us. This kind of aggressive, but this guy. So it's starting to look like that when we connect them up. So we're going to keep going until we hit the edge of the graph. So let's keep going. So once we get to pi, our next angle that we have, that's our 7 pi over 6. Seven pi over 6 as a decimal. We should get 3.7. So 1, 2, 3.7 over there. And we're gonna do our 5 pi over 4. About 3.9. So it's getting real close to that 4. Oh, I just saw my screen blink in my Precal. Yuck. Go back. And then we got our 4 pi over 3. 4.2. So we're out here. Oof. And then our 3 pi over 2. 4.7. So that's going to be way down here. We had these guys connecting up. Oh, I get it on the same color. So it should be this guy. And our very next one, our 5 pi over 3, 5.2, and we're then off our graph. So if I have my 5 pi over 3, now we get 5.2. That's going to be here-ish. So I'm off my graph. So I'm going to stop right there. With the spirals, they don't have an endpoint. So we kind of have to stop when we figure out when to stop. And for the most part, the easiest way to do that is to just kind of stop when we're off the graph. So our graph is this little spiral right here. So the spiral of Archimedes, that's when we have like a number there. It's not going to have a trig function. We could have like a 2 theta. We could have 2 theta plus something. I could have 2 theta plus 2. But it's not going to have a sine or cosine or anything. So it's mostly just going to be switching our angle into decimal. Okay. The very next one, number 4, is a circle. It's just like the one we did for number 1. So I'm actually going to have a skip number 4. Because I want to look at number 5. But I'm going to cut that one from the notes next year because we don't need another circle there. I'd rather us have more time to work on stuff than to do more notes together. So let's take a look at number 5 here. And we want to know, first things first, what shape is this? Our lemniscate. So this is our lemniscate. And they have a period length of pi. So we're going to need every number from 0 to pi. So we're going to do all of our unit circle values. So we're going to have our 0, our pi over 6. So that gives us our full period. Then this one's a little bit weird because we're going to find our r, but our formula is for r squared. We know our r squared is going to equal 4 times cosine of twice our angle. So 2 times our angle. I'm going to start by doing 0. And that way we can kind of see what's happening here. So cosine of 2 times 0, that's the same thing as cosine of 0. So we have 4 times cosine of 0, What is cosine of 0? 1. Cosine of 0 is 1, so it means 4 times cosine of 0 is 4. So our r squared is 4. So what's r? Positive or negative 2, plus or minus 2. So that means for angle 0, we have a point at positive 2 for a radius and a point at negative 2 for a radius.
So we connect those or no?
We're not going to connect those yet. Let's see what they look like. Because we connect this to this to this, not necessarily within its box. So we're going to connect these guys together. Whatever's happening there. So let's look again, see what happens with our pi over 6. So our for cosine 2 times pi over 6, which means we're looking really at pi over 3. Because that's 2 times pi over 6. So that's the same thing as 4 times our 1/2. So our r squared equals 2. So what does r equal? Yeah, but it's plus or minus that square root of 2. Square root of 2 is also, like, since we're looking at it kind of decimally wise for graphing stuff, 1.4. So we're going to have positive or negative 1.4. So on our pi over 6 angle here, we're going to have at positive 1.4 a point and at negative 1.4 a point. I took the pi over 6 times the 2 in here. Maybe I didn't. So this is the 2 times our theta times our pi over 6. I just simplified it to get the pi over 3, because pi over 6 times 2 is pi over 3. So let's do another one. Let's do our pi over 4. So our r squared, I'll write out the full thing this time. Our 4 times cosine of 2 times pi over 4. That's the same thing as our 4 times cosine of pi over 2. What is cosine of pi over 2? 0. So if our r squared equals 0, 0 is 0. As I say, you can put plus or minus, but plus or minus 0 is just 0. Oh, and the screen's going to freeze out for a second. Hang on just a second. I got to get my screen to refresh. It froze on me. Ooh. The software crashed hard. I think my computer might have crashed.
This is like 2 separate graphs.
We'll see. Hang on. I promise. I promise I'll show you. It kind of did. No, just grumpiness. It really is. All right.
So is the next one undefined?
Uh-huh.
Wait, so what does that
Okay.
mean?
Oh, we put an open circle.
Nope.
What?
Hang on. I'll get there. Give me a second. I just got to restart the software.
Isn't an undefined point like an open or?
So if we had like a single point that was undefined, thinking rational functions, yes. But it's not just that the point is undefined. There's whole sections that we're going to have that are undefined. So, let me get, can we connect? Can y'all talk to each other, please? Thank you. There we go. No. There we go. So what we have here, with looking at these three pieces, we can actually see our first bits of connection. We have three neighboring points. So from our 0 to our pi over 6 to our pi over 4, those guys connect. We had two sets of values, so we actually can connect these 3 points as well. These three connect to each other. So the positive 2 to the positive 1.4 to the 0. The negative 2 to the negative 1.4 to the 0. So those pieces connect together. Let's keep going with our points and see what's happening here. So with pi over 3, when we do this, substituting that in, I'm going to come over here to the right just so I have a little bit more space. So if we do our r squared for cosine of 2 times r pi over 3, that's 4 times cosine of 2 pi over 3. What is cosine of 2 pi over 3? Yeah, because our cosine of negative 2 pi over 3, that's our negative 1/2, right? Negative 1/2. So our r squared is negative 2. What's the square root of negative 2? Undefined. It's imaginary. So it's not just that we have a hole or a discontinuity. We have a section of imaginary numbers. So this guy's undefined. We can't do anything with it. What pi over 2 is going to be very similar. It does the same thing. When we find our cosine of 2 times pi over 2, cosine of pi, it's also negative, so we're still undefined there. What about 2 pi over 3? What's cosine of 2 times 2 pi over 3? It's going to be a negative cosine again, so again, it's undefined. What happens for 3 pi over 4? 0. We're finally back in business.
And then it's 1.4.
So then see what happens for our 5 pi over 6. It's going to be, again, we're going to have our plus or minus 1.4. Have faith in yourself, Justin. You were right. And then for pi, what do we get? 2. But again, plus or minus.
So we just leave it how it is.
So, well, let's take a look. If we look at 3 pi over 4, that's this guy. We're good. It's already on there. But 5 pi over 6, that's this angle. So I need to have a point at positive 1.4. So we're out here. And a point at negative 1.4. So down here. And it's going to connect up to our pi that has points at positive 2 and negative 2. So this is going to connect up to the 0 and to the pi. So it looks like a little infinity symbol. That is what the lemon skeets look like, because they have that r squared. We wind up with a lot fewer points, but it makes a little infinity. Okay. Questions on our lemniscate? Okay, I actually want us to jump 6 again, and I want us to go to 7. So we're skipping 4 and we're skipping 6. 6 is a limacon that we did one like that yesterday. That was like our second one, the limaison. So let's look at number 7. First things first is, what shape is this? A rose. So roses are a little bit weird, so let's look at our rose. So the first thing we're asked is, how many petals is it going to have?
3 or 4.
I'm going to say, that's the question, isn't it? So look at our equation. So normally when we look at our roses, that was when we have our R equals a cosine of n theta. And n is the guy that we're looking at. So if n is odd, n equals 3, which is odd. So if we have an odd n, the period is going to be pi.
If it's even,
If it's even, it's 2 pi. And if it's odd, we have n petals. So we're going to have 3 petals. So then this asks us kind of a weird question of, what is the maximum value? Meaning, what is the very, very, very biggest answer we're going to get for R? You're thinking angles, not thinking that. We're thinking, what is going to be the farthest out we get? So what is the biggest value we get as cosine of an angle? 1. Like the very highest cosine can go is 1. So if cosine is 1, what would our R be? That would be if you're thinking theta being 1. It's not that cosine of 3 times 1. This thing, cosine of 3 theta, would equal 1. 4. So our maximum value is 4. So what that tells me is the farthest out, this is going to go on our circle, is out 4 to radius 4. That's going to occur when our cosine of 3 theta, when this guy is 1. When cosine of 3 theta equals 1. Or when cosine of 3 theta equals -1. Because that's still going to go out 4. It's just going to go out on a different angle. So we're going to solve those. Oh, snap, review of old skills. What? Who's she? So let's find all values on our interval that have this value. Solving this. So imagine this doesn't have anything else to do with polar. Just looking at this. How would we solve cosine of 3 theta equals 1?
so 2 pi over 3 equals 1. Oh, wait, what?
Hang on a second.
Oops.
Walk me through what we're thinking.
The inverse cosine.
So you
You can do it that way. Yep, you can do arc cosine. I was like, I did these as like a u substitution. So doing cosine of u equals 1. So we can figure out when that is. When does cosine equal 1?
I don't know. 0.
At 0. And it repeats every 2 pi n. Because every time it goes around the circle, it's going to make a 1 again. So if we have our 3 theta equals 0 plus 2 pi n, how do we get theta? Divide by 3. So we're going to have our 0 plus 2 pi over 3 n. So every place we're going to have a maximum here is going to be when it's 0 or 0 plus 2 pi over 3, so 2 pi over 3, or plus another 2 pi over 3, so 4 pi over 3. And it would continue on and on and on and on. If I do another one, we'll get to, another 2 pi over 3, so that's 6 pi over 3, or 2 pi. Then we're going to do the same thing for cosine 3 theta equals -1. Same kind of vibe. So I tend to do these as more of the u substitution, but if you can make the mental jump without it, that's totally fine. But I'm going to set it up as cosine of u is -1. So our u is going to be what? Pi. Plus every time it reoccurs, 2 pi n. So our
Divided by 3.
3 theta, yeah, equals pi plus 2 pi n. This in. So our theta is going to be pi over 3 plus 2 pi over 3 n. So we're going to have different values up here with our pi over 3 and our plus 2 pi over 3. So we're going to have pi. Then we would have 5 pi over 3. And it would again continue onwards. Both of these continue out to infinity because they're periodic, they're reoccurring. What's up?
What's with the dot after 2 pi?
Because I could keep going. I could keep adding 2 pi over 3. I could keep adding 2 pi over 3. I could just keep going. These are, so the blue ones are the answers for cosine equals 1. The purple ones are the answers for cosine equals -1. Yes, dear?
So you couldn't just put theta equals 0 plus 2 pi over 3 as like the maximum? Or do you want us to actually write the values?
We're going to want to write some out because we're going to use them as points when we're graphing.
Oh, okay.
So having them listed out will help. So the other thing to notice on here is I didn't pay attention to my period length at all on this. So the only ones we're actually going to graph is anything that is between 0 and pi. So we're going to use 0,
Pi over 3.
pi over 3,
2 pi over 3.
2 pi over 3,
And pi.
and pi.
Is that our order that we put in the...
Doesn't really matter. So what this tells me is that for all of these, we're going to be at our radius of 4, because this is when our cosine was 1. And on these ones, we're going to have a radius when this was -1, so it's going to be -4. So I know, as of right now, 4 points. As it sits, no extra work. This guy is going to have a radius of 4. These two guys are going to have a radius of -4. The other thing we'll ask you for on these is when are the zeros. So that's doing the same kind of thing one more time. I promise there's a reason for this. I'll show you in a second. Our cosine 3 theta, looking for that to be 0. What angles are we going to have zeros on? How can we figure that out? Same kind of thing. When does cosine equal 0?
Pi over 2. 2 pi over 2.
Yeah. So we have our pi over 2, and then it repeats at 3 pi over 2, and then we get pi over 2, and then 3 pi over 2, and then pi over 2. And so it's repeating every pi n. So if we have our 3 theta equals this, where are we going to get zeros? What is our theta going to be? Mm-hmm. Yep. So our zeros are going to happen at our pi over 6. And then if we add pi over 3, so that's adding 2 pi over 6, we're going to get pi over 2. And then if I add another 2 pi over 6, we're going to have 5 pi over 6. And what all of these are is these are going to be zeros. So I know those points as well. So if we look at our table, thinking about all the points we fill in, we know this one has a period of pi. So looking at all our unit circle values, which we don't necessarily have to fill in the whole table. Once we get a little bit more familiar with these, we're going to be able to do it with a way smaller table. But you can always do a full table if you want to. That's totally fine. So filling in that top half, we know several of the values. I know pi over 6 is going to be a 0. I know pi over 2 is going to be a 0. I know 5 pi over 6 is going to be a 0. I know 0 and 2 pi over 3 are going to be maximums at 4. So 0 is going to be at 4. 2 pi over 3 is going to be at 4. Because those both came from my cosine being 1. And our equation up here, 4 times r1. When our cosine was -1, so pi over 3 and pi, that would be when 4 times -1. So my pi over 3 is going to be at -4. And my pi is going to be at -4. We only have 2 empty boxes to fill in. So we need to calculate 4 cosine of 3 theta for pi over 4 and for 3 pi over 4. So we're going to do those two in the calculator. We should get our -2.8 here. And 3 pi over 4.
2.8.
We're going to get a positive 2.8. So let's see what happens when we plot this up and what this is going to look like. I'm going to get my chunkier pen. So if we have 0 at radius 4, we've got a point over here. And by the time we get to pi over 6, we're at 0. So these 2 points are going to connect like this. For pi over 4, that's this angle here, we're at -2.8. So we're back over here at this point. So this one's going to connect out to here. For our pi over 3, we're at -4. So we're down over here because we took our negative over here. So this is going to be that point right there. For pi over 2, we're back to 0. So this thing just loops itself back in like that. For our 2 pi over 3, we're up at 4. So this is making a big old loop up here. Boop. Our 3 pi over 4, we're at 2.8, so it's down here. 5 pi over 6 is at 0, so we want to get in there. And then pi is at -4, so 1, 2, 3, 4, back over there. And we have ourselves a flower with 3 petals, which is exactly the number we were expecting to have here. So it loops around itself, making this shape. And it will just keep going. If I kept going, if I did like 5 pi over 6, it would keep going. We were here, so it would be looping back around, looping back around. Okay. Tomorrow we'll do the last rows. We'll do number 8 just so we can see the even rows versus the odd rows. And then I'll show you what we're going to do for the project and how we're going to do that and how you guys can start that planning process, because that'll be the end of it. So tomorrow we'll finish out that last rows. I'll show you how to do things on the computer to plan things out, and we'll talk about the project. Okay? So